Hello, everybody, and welcome to today's vOLTHA TST. Thanks for joining. As usual, the call is public and recorded and will be shared live on YouTube, so please be mindful of the comments you make and the information you share. First of all, I would like to get a few topics out of the way as an update. The first one is that we made a little bit of progress on the initial discussion that we did the last week. We merged the OpenVOLTHA adapter patch, and the core one is yet to be merged because of some errors that are unrelated, but we wanted to investigate to make sure that we have clean runs on the pipelines before we can actually test this one. So that's why it's not yet merged, but we are making very good progress. The other great thing that was done yesterday and the days before, especially Ken and Girish, thanks for that, is that we got merged the changes that were needed to move to a streaming service from containers to containers. So to make sure that the adapters are connected to the core and they can talk to each other, and the adapters between themselves as well. We are now using a streaming gRPC service instead of more of a polling mechanism. So that's really good. And that is also merged, so that is in the upstream code. Girish, Ken, do you want to add anything?
No, yeah, you said it all. And again, the streaming is really for process monitoring to see if the ever end is there or not. The polling was okay, but we get a better response time if an adapter goes down by using streaming than polling. And that's it.
Yeah,
okay.
That's it, Andrea. I think all the tests are passing fine.
Good.
There are a couple of failures, but they're unrelated to the changes that Ken has done. I think that we need to investigate.
Yeah, this is great news. I know Elia started some investigation with a little bit of help from what I could spare from my meetings today as well. So I think we can make good progress on those failures. But this is great stuff from you and Ken, especially Ken that wrote the code. Thanks for that.
No worries, thanks.
Okay. So the real topic of the day are kind of two. The first one that is very dear and important to us is the microservice controller, the new microservice controller that we want to put into the system instead of in replacement of ONOS. And last week, as you guys saw, Netsia did a proposal on what they would like to implement, and based on the feedback that we had as ONF in the document. And this week we have another proposal, and at the end, I hope there will be a discussion on maybe how we could possibly put these together. But let's first hear from Radisys, Raj and Shriki, on their view of an implementation for a lightweight microservice-based controller for vOLTHA.
Andrea, thank you. This is Rajesh Chanduri. I think most of the folks in the TST probably have heard me or seen me before somewhere in ONF. And thank you for giving us the opportunity. Today, we have Shrikant Yandapalli, we call him Shriki. He's our chief architect. He's based out of our Bangalore office, and he's on the call. We should also have a couple of more colleagues of ours, Abhilash and I forgot now. I think who is the other one, Shriki? That's Srikar, right? Srikar.
Yeah, his name appears as S.
Yes, Koneti. Yes, sorry. Okay, I was looking for Srikar and I couldn't find it. Okay, and Srikar Koneti and the call, and we also have Suhas who just joined us from our Bangalore division, if I may. So what we will do, Andrea and for the STM TST, is go over our proposal for, if I may, the ONOS classic replacement. I think we all have understood how it has served its purpose, and it has served very, very well to bring us the CIBA vOLTHA stack to where it is today. But I think it is also getting to the point where, for all the things identified in terms of scaling, what have you, we could be bringing in a modern, newer architecture solution here to sort of get that, if I may, performance solution in terms of ONOS classic to what we can call it micro ONOS. We can call it whatever we want, we really don't care what we want to call it, but we wanted to also propose an offer here, and then discuss the merits and see how we as a community can take this up and get this out, if in either in 2.10 or at least if not in the vOLTHA 2.11 release. Is that good enough, Andrea, or do we need to set any more?
That's perfect. I think you guys have a presentation, so if you don't mind, just sharing the screen and fire it away.
Okay. Shriki, are you in a position where you can share the PDF and present, or you want me to?
Let me find the PDF first.
I can also bring it up. That's no problem. You guys can see it here.
Yeah, thank you, Andrea. In which case we will, yeah, you present will speak through the slides.
You can just feel free.
Okay. Short introduction.
We don't see it yet, Andrea. Yeah.
Or is it I see it?
Oh, I see.
I
Okay,
think
okay. Go for it. It might be something
Okay.
on my side. Go for it, please.
Sure. Okay, so we have, I mean, like Raj introduced, the ONOS laid the founding stone for the SIBA stack, and we are here because of ONOS. That said, we also have a reason to come up with something lighter and ONOS has a lot more functionality than what you need from pure, let's say, pawn management perspective, pawn control perspective. So there's a need for a much lighter version of the same. And we have felt it in our software stack as well. And hence we came up with this idea of writing out what we didn't call it micro ONOS, but that's a name that today is preferred by the community, and we're perfectly fine to offer what we have as micro ONOS. Essentially, it has been written only to support vOLTHA, in the sense that it's only to support the SIBA use case, where we're only talking about managing OLTs and the sessions and subscribers connected via the OLT. I'll just speak briefly about what we've done here. If you look at some general points, we developed it using Golang, and thus the image size is small. And even the running footprint is small because of that. And Golang has a very good build tool chain, and hence the build complexity is reduced. It builds pretty quickly, and obviously as development team will benefit from it. And it supports, since it does not use a lot of CPU and RAM, we can support lot many flows in an instance of running micro ONOS. And it is built to be using microservice architecture, where the context is separated from the execution itself by writing the latest state into the database, so that you can bring it down and bring it up again, and you'll start from where it left. So you have this microservice architecture as well. Coming to northbound interfaces, currently it supports two northbound interfaces. It supports REST for configuration and supports Kafka for indications. The asynchronous indication generated towards the application to take any necessary action based on that. There is some difference in the way the northbound REST, in case of micro ONOS that we have, behaves from ONOS. The intent is not to go into a lot of detail in this call. We just want to introduce the concept first. And we certainly will take more time in subsequent calls to explain what we have, the differences, etc. That is set for a different time. But just so that you know, there is that one point where we do differ from ONOS. We have to figure out the right way of reconciling the differences. But that said, the functionality is not very different. It's a matter of putting few heads together and identifying what we believe is the right approach for reconciling. On the southbound interface, it'll be more clear when we show the picture in the next slide. The OF agent that was written in Golang, that was available in the community, was used to form the lowermost communication layer towards vOLTHA. I do not think we changed much, or I would like to say we did not change anything at all, maybe a very minor differences. We expect that to interface or integrate interoperate with vOLTHA with very minimal effort. And this runs in the context of the micro owners. It is not run as a separate process. It is the lowermost communication layer that connects with the vOLTHA. And the flow structure, the data structures used, the gRPC used, the schema used, all of that is almost same as what's currently used. But at least when we started, it's same as what vOLTHA was using. I don't know how much that interface has changed, but I would expect that to be, I mean, even if there was some change, it should be easy to reconcile the differences. Okay, and then we did make some modifications in terms of how we use audit. This is mainly for improving performance, and also audit. The frequency of audit would determine how quickly, you would correct a mistake, correct error in the flows that got that failed addition or most failed addition. So we did not really rely on audit. Audit was only to bring vOLTHA back up to speed when vOLTHA restarts. So we do audit only when the vOLTHA restarts. Otherwise, we do the polling intervals only to discover new OLT devices. We have one, I guess this is not going to impact how it integrates with vOLTHA, but we have a synchronous call to vOLTHA in the sense that when a flow addition or a flow deletion is requested, the act on the vOLTHA is completed and vOLTHA responds only after everything is completed with a success or a failure. Okay. Any questions on this? I saw some questions from David Bainbridge. Let me read that. Minor issue. ONF already has a project named MicroONOS. Does this work built on that? If not, won't calling MicroONOS cause confusion? We had a conversation, David, on this with Andrea. Whatever we implement here is going to go under the umbrella of MicroONOS. To the extent we know, MicroONOS today, where it stands, it mostly supports a RAN use case and hasn't implemented OpenFlow or an OLT part of it. And hence, it might just might be a good complement and just fits well under the MicroONOS umbrella.
So you're going to contribute this to the MicroONOS project then?
Yes. Yeah. I mean, we contributing it to ONF.
Let me maybe interject here and just mention the fact that whatever the name is, MicroONOS is a way to call the existing stuff. At this point in time, this has no interaction with any existing service. So I wouldn't get too fixated on the name. I do agree that maybe calling it MicroONOS is not the best. Let's just say microcontroller for vOLTHA or vOLTHA controller. I would just call it like that. I know that the internal code name for Radisys is LWC, lightweight controller. That's fine to me as well. In the sense that the idea is that if possible, this will be open sourced. And if possible, it falls under the same principles of MicroONOS, the thoughts of being a microservice, etc., but it has no interaction with the existing MicroONOS. So we could call it separately, and if in the future, in a different way, like lightweight controller for VOLTA, or something like that. And then if in the future it gets tied into existing MicroONOS services such as ONOS-Topo, then we move it under the MicroONOS umbrella. But at this point in time, this is more of a more of an umbrella term to say that is a controller in microservices and things like that. So
thank you. Yeah, maybe we are perfectly fine either way, just so that you know.
I understand. I just, again, minor issue, and I know it's just a naming issue, but you call this MicroONOS. I'm going to expect to get this when I download the existing MicroONOS project from ONF.
Okay.
Just wouldn't call it that until it's integrated, right? I think we're going to cause community confusion.
Yes, absolutely, David.
We can change that, David. Definitely.
You're right, David. As we just said, David, we used it as a MicroONOS to say that, we can name it whatever we want it. And if it makes it easier for the ONF community to put this under the umbrella of the current MicroONOS, so there is no a perception that there is a different controller when there is an existing controller for all of the ONF community or the open source community at large, David. We can call it anything and whatever we want. We just wanted to, we didn't want to create a confusion by creating one more name outside of the existing name set, David. That's it.
Understand.
Okay.
Thank you.
A quick question about the audit that you have there. Is the reason why you don't do an audit for the flows because those are synchronous call now?
Yeah, we did have, I mean, we never built audit also, mainly because it was seen as a big performance bottleneck for us, at least. As you increase the number of flows, if you audit 1 million, I'm just taking an example, 1 million flows, it'll have its own overhead. So we didn't want to rely on audit to start with. And on top of that, and subsequently, we also built the entire thing to be synchronous. And then we completely got rid of even the need for audit, by the way.
Okay.
And also, I think this would be one of the things that I would like to go more to an events mechanism. And we do have an events stream from the vOLTHA core that throws up events on logical device creation ports and stuff like that. So it should be fairly straightforward to go to that mechanism instead of auditing.
Should be possible.
There could also be kind of a change note, well, not necessarily a change notification, but a change counter, if you will, right? A commit number, if you will. And so every time a flow is changed, whether that's on per device or per the whole application, so you can do a quick check if you're still in sync with what vOLTHA has.
There are many ways to do this. I wouldn't. I mean, this is fairly technical detail, and I think this could be saved for another time. So I would like to get Tricky to continue to get this overview, because let's not forget we need to agree on what are the next steps as a community in general. And that's my focus of today.
Understood, Andrea. So then we can go to the next slide. I won't take too long, and maybe take the discussion to what you want to do. I mean, this probably is picture reasonably explains what we've done. Just to reiterate, we have a three layers in the lightweight controller. Yeah, right. And then the lowermost layer is a protocol layer that speaks the existing vOLTHA gRPC. Then we have a devices layer that's essentially responsible for maintaining the the flows, the meters, etc., that are configured on the device, and also obviously everything that comes from the OF agent lands in the devices, and then the devices layer is responsible for passing it back to the application. And I mean, I wouldn't say it's much different from ONAS. You have the core, you have the protocol, you have the applications. You can call devices the core layer, the protocol, whatever the protocol is the protocol, and the application is where you build the applications. And you can look at the applications. We have Volt app. That's essentially the application that understands that every Uniport is an ONT, right? And how the naming comes about for each port, etc. All of that logic is in the Volt app. And then you also have some packet processing apps like DHCP relay, PPP over Ethernet intermediate agent, right? And then there are KPIs so that you can monitor the system. And then a northbound handler to interface with the configuration. Since it's a microservices architecture, we do store the context in persistent store in the form of etcd database. And then we have Kafka for indications to the application, asynchronous indications. So this kind of covers the overall architecture, and also I guess it's pretty in line with what you expect, but we can take some questions on this.
Why did you decide to keep the OF agent and OF protocol between? Go ahead.
I know that was a question that was coming, and I was not fast enough to preface this. That OF agent is, and I want just to be clear, I talked to Raj and Sriki about this architecture, so I know a little bit. I'll let them maybe explain better, but that is just the southbound part of the OF agent. So effectively, when you see OF agent there, you have to think it like you took the OF agent we have right now, which is effectively a translation layer between OpenFlow to the gRPC calls to vOLTHA, and you just cut his head, which is the OpenFlow part, and keep the lower part of the body, which is the one towards vOLTHA. And that is what they kept here.
That's a good explanation, yeah.
So it really, okay, so it really has nothing to do with OpenFlow at this point, you're saying then?
No, it's just the same code. It's just same code, David, yes.
So they only, as far as I understand, the only thing that is remaining about OpenFlow is that we are still using the OpenFlow protos, but we never convert them to the OpenFlow protocol.
Yes, indeed. The flow mod is kept. The OF13 protos are kept, but they are not used on the OpenFlow channel. There is no OpenFlow channel. There is no OpenFlow serialization on anything that is not the gRPC stream to gRPC call to vOLTHA. Anything that's not protobuf.
Looking at the diagram, like packet handler, event handler, I assume they are all separate microservices, right? How do they communicate among each other? Is it all Kafka? How does that happen?
This is all one microservice. When I say the application layer, devices layer, and the protocol layer together forms one binary and one microservice, including obviously the libraries as well.
Oh, okay. And how about HA? Like, how about like if it goes down, like, is there a loss of data, or how does that work?
No, and the context is stored to the database etcd. So it'll spin up again and have the entire context available. So I mean, let's say we've tried this as well, that you can bring it down and bring it up, and then it'll just work as if nothing happened. I mean, obviously a little glitch does happen, but for the most part, it behaves as if nothing happened, nothing bad happened.
Okay, so when on a restart, you'll do an audit with vOLTHA first, or you will assume that whatever you have in your database are the source of truth.
What we have in the database is the desired state as a controller. And then we do audit vOLTHA and reconcile the differences. As in, like, if there is a flow missing, we add. If there is an additional flow at vOLTHA, we delete, so on.
Okay.
Sorry, if this is a single container, then how do you onboard the applications? I mean, there are a few different applications on application layer. And
yeah, that's one thing that, sorry. Yeah,
go ahead.
Yeah, that's one thing that we need to debate, whether you want to onboard applications or whether you have these applications always running and the configuration controls what happens with a particular, let's say, call or with a particular subscriber with an ONT. That's something that we can debate as to what is the most desired approach. Everything will have some pros and cons, right? Performance and etc. So that I would leave it for a different discussion.
I think that at the moment, the answer to that question, if I understand it correctly from this presentation, is that those applications are always running. Is that correct?
They're always running, yes, yeah.
Okay.
In the sense that, yeah, I mean, when you configure a subscriber and say you configure a DHCP, or for an ONT, you configure DHCP relay, only then the DHCP, when the DHCP packets arrive, would something meaningful happen for that particular DHCP packet. If nothing is configured, no flow is pushed to the OLT, no DHCP packet comes up. But just in case if a packet does come up because of some error, it just gets discarded because there's nothing configured for that particular ONT for the LWC to do any DHCP relay processing.
Okay.
So will that micro-owners, if we call it that way, there would be one per vOLTHA stack, or will there be like one for multiple vOLTHA stacks?
This can support, I mean, this supports only one vOLTHA stack today, though it would not be very difficult to support more than one, but today I think it supports only one vOLTHA stack.
So in this
I
sense,
know.
it is very similar to what we saw last week, because that was the same idea with the NetShare proposal, where you had one controller controlling one vOLTHA stack, where you could have 2-3 OLTs underneath one vOLTHA stack. Go ahead, Ken.
No. That's all. I'm just wondering if is there a goal to have it limited to one stack going forward, or is the goal is to have it like supporting multiple stacks?
I think the goal is to have it supporting both options. We saw that there is demand in the community and at large in the operators for one-to-one because of the island approach, where if something fails and you have a one-to-one mapping, it's effectively failing just one OLT. And also because they would also like it lightweight enough that it can be deployed in not powerful machines, them being servers very close to the edge, or even fairly powerful OLTs themselves. So the goal is to have it support both, but mainly there is request for a one-to-one mapping.
Okay, because if you have one-to-one mapping, then maybe it's you can via configuration, like you can limit the number of apps that actually is valid for that environment. But if you have it's going to support multiple stacks with different kind of configurations, then it can be a little bit tricky to have only one microservice for the entire thing.
Did you mean from a performance perspective, or?
Not just from a configuration perspective, right? So you can have two different stacks with different configurations, and maybe it requires different set of apps.
Yeah, so the current design, again, we can obviously debate this and figure out if something else is better. Current design is that you can have both the DHCP relay app and PPP over Ethernet intermediate agent app. Their presence does not mean DHCP relay is activated on the device, right? What you do on the device is a set of flows that will be driven by, let's say, when an ONT comes up, whether you associate a DHCP relay feature with it or a PPP or Ethernet intermediate agent feature with it. Based on that, you would configure some flows and the packets would come up and you process. So in theory, having these apps does not mean you're forcing that feature on the OLT. That's one part. Second part is then we need to debate when do we not want to have, what would be the benefits of restricting the number of apps running in this, let's say, LWC. What do we gain? Is it the processing, the image size, etc.? We certainly can take have a more detailed discussion on that and see what works well, right?
Okay.
So
maybe just a quick one. The etcd container that you have there, is it a shared etcd with vOLTHA, or is it a separate etcd instance there?
LWC, as part of its bring up, you configure the endpoint of etcd, and it just goes there and basically uses it. So it could be shared between vOLTHA and LWC. You don't have to create one for LWC.
Oh, okay.
Yes, I think the question about the database should be, are the data shared with vOLTHA or not? Then whether you use the same database or not, it's a deployment choice.
Yeah, data is not shared. So in the sense that LWC does not use the database to communicate with vOLTHA, it stores for its own purpose and uses the gRPC to communicate with vOLTHA. So in that sense, it does not share data, but it can share the database with vOLTHA.
So that's interesting. There was a discussion last week around what makes sense to keep in the database, and there was actually some thoughts of not replicating the device at all in the controller. So just if you're interested in the device, given that it's effectively, as we were saying, most closely related to a one-to-one or one-to-few or vOLTHA stacks. You could go directly to the relevant vOLTHA stack to achieve that information, but definitely we would like to persist the flows. So I think this goes into that direction as well. That is good. We could debate either to store or not store the device information, but that depends on the
Understood. Yeah, understood what we gain and what we lose, coupling between two layers, etc. So yeah, we can debate the pros and cons and yeah, then make the decision.
So I'm just struggling with terminology here, I suppose. This was, if I understand correctly, this is one process, correct?
Mm-hmm.
Okay. So when you say this is a microservice architecture, maybe you didn't hear that, or you call this, micro-onus. There's an implication there's some microservices here, but this is one process. So what, in your opinion, are you, in terms of microservices architecture, does this embody?
At least the way we are using it, I don't know if it agrees with everybody else's opinion, is that you separate the context from the execution. And then the basic thing is that these can be brought down and brought up pretty quickly because it's just instantiating a process as opposed to instantiating VMs in the world of VMs, where it takes much longer time to instantiate a VM. And the data is, and also once you're willing to bring it down and bring it up, that means that you don't store the context within the process. You store it in a persistent store outside. That is what we've been using as microservice architecture or microservice concept, if not architecture, concept.
Okay, so it's a stateless service, and that's fine. But thoughts about, you're embedding all the apps that you could possibly need in any workflow within the single process. My assumption is you guys made that decision for probably performance reasons. But was there a thought to be able to dynamically add apps without having to rebuild this service?
Yes.
We didn't have, we didn't have the need. Okay. At the same time, it also, I guess with everything comes some pros and cons. For us, this made sense. We can always say what are the pros and what are the cons, and determine what we want to do subsequently. But from what we needed, this was sufficient because we didn't see. We have to think through full architecture. Like for example, packet goes through every app. Packet goes through only one app, like in the packet handler. I don't know. So there is complexity in having too many apps as well.
And Ricky, if I may, very quickly, just one quick clarification. David, that's a good question. Very good question indeed. What we're showing you is what we have done. But this is not to say by any means or any stretch that this is how we expect it to be used in the community. We are willing to bring the core pieces of the code, source code, if I may, correct? And as a community, David, to your point, if we want to take it to the much higher fine-grained true, or whatever you want to call it, an definition of microservices by splitting these things up into individual microservices that then communicate over a common infra, that is perfectly fine. I don't think we are necessarily against it. Shiki, correct me if you have a different opinion there. I know we talked about this.
Yeah, I think we need to debate it. I don't say that. We are not against it. We have to see the pros and cons and how big is this, and will the apps appear? We have to visualize a few things, and then if it does make sense,
correct.
To do it. Yeah, I'm not against it, like you said.
Right, and there's other issues between packet processing performance versus
there you go, David. I was going to go there.
Right, and I get that, and so you can say, look, we can't split out DHCP, PPOE, all that type of stuff, because there's a packet pipeline, and that's got some very restrictive constraints on it. Versus the app might have a different restrictive. And again, I don't know where it might make sense to break this up into multiple services. You have to take into consideration where you want your failure zones, all that, your blast radius, all sorts of things. Correct. I'm just curious what kind of thoughts you put into that in the background. But I get where you're coming from. All right, thank you.
Yeah. So in principle, we are not against re-architecting this further if the community feels that is the best way to go about dealing with it. And we have addressed a certain use case for a certain set of customers that required us to go the path we did. But then, as we talked about, yes, if we want to keep some things in a microservice context, if I may, for sake of performance, because that's the really reason why we're moving from classic to this alternative solution. And if we want to play with it, get some characteristics data out in terms of performance difference, if I may, and then decide on what is the best way as a community to go, completely fine. Sorry, Mathayo, I just wanted to complete that thought. Back to you, please.
No, yeah, don't worry. I was just saying that I think we need to ask ourselves whether a dynamically load application is even a requirement, because I think the deployment features are pretty well known upfront, and one way to have different application for different operators is to manage that at build time, because I don't see that changing very often at runtime. And if it happens at runtime, most likely you'll have to upgrade the software anyway. There's not a huge difference to deploy a new version of the controller that same set of application.
So
that might be. And I'm not arguing that that's the right solution, but it's something we need to consider, that Ono had that capability to load and unload application, but it might not necessarily be something that is required for this use case.
Agreed.
And
Agreed.
I totally agree with what Theo said. I think it can be evaluated on a case-to-case basis, and also in the initial proposal and thoughts that we had at ONF, that was not really something we actually wanted to include, because I mean, it is also true that these are all in the end code paths that you can exercise or not, and if it's done properly, like it is done in VOLTHA, for example, with the library, with VOLTHA Let Go, you could reuse as much as possible of that and not impede the workflow that does not use it. So I don't see actually application loading as a requirement. The only reason why I could see dynamic loading being a requirement, or more than that, splitting the application out and having it as a separate microservice, is replicating it in case of extreme load. Because then you fine-grain the replication of each, like packet handler, for example, if you have an extreme load. But I do not believe that for the numbers we're talking about, especially for the initial one-to-one, that both this presentation and the NetSet presentation seem to strive for an initial work, I don't believe we need this loading dynamically for these numbers. That's plain and simple.
Yeah, and that's fine. I agree, actually. I just think this represents a service. It's not even a collection of services. It's one service.
Agreed, David. Agreed. Yes, it is in a microservice environment. It uses tenets of microservice like cloud native architecture, but it is not a multiple microservice element project at the moment. Yes, agreed. And that's why I would venture more towards like a lightweight controller for VOLTHA name, or like whatever we want to decide to call it, without calling it multiple microservices or things like that. But that's more about another discussion, in kind of independent of this specific technical proposal itself.
Yep.
I've come to the end of the slide deck. We just wanted to introduce first what we have, what we are planning to offer. What would be the right next set of actions? I mean, in this call, and also as going forward.
So there is one clarification that I would like to ask. That's actually two, and one is that this is currently, as I've understood, this is currently already in production with customers. Correct?
That is right.
Okay, good. The second one is that. Yeah, go ahead.
No, finish, please.
The second one is what is the interest of and what is the I could say the plan, if any, from Radisys to open source this? And I know this is a question for Raj. You might not want to answer this right now, but from a community perspective, we care about if you have something which is already in production, is there a possibility that we can open source this? And the same thing happened. I was asking the same thing for the Netsia proposal last week, and then we'll come to that.
Yes, Andrea, that is the intent behind this proposal, is to bring this into the open source community. Yeah, absolutely.
Is there a timeline for that?
David, we just have to figure out when we can bring this in. From what I understood, I think the initial thoughts were to bring it in by 2.10, but now it seems like 2.10 is already full, and it is now slated for 2.11. So we can work in that time frame. I don't see any issues with that.
Is there a plan, talks, anything? I mean, we've got two proposals here for kind of a lightweight controller on top of vOLTHA. Is there a plan to reconcile these, or do we expect them both to be built and put into production? And if so, is there some divergence that we, in terms of lower level capability? I mean, you had mentioned the REST API was slightly different here, so potentially already seeing divergence. So again, what's the plan to deal with both of these?
Let me pause before anybody answers, and let me state that this is the key topic for me as well, because from a vOLTHA community perspective, there are two set of elements here that are at play. The first one being the fact that we have diverging resources on the controller, while there could be an option to converge these resources instead of having them on two separate projects. And I mean the Netsia team and the Radisys team, instead of working on their separate solutions, one was presented last week and this one, could work together. There are differences, like the language of choice is clearly one, this one being in Go, and the one of Netsia being in Java. And the second thing that we have at play, and that is very key to me, is the vOLTHA protos, because both of these controllers, both of these proposal, and ours as well, our idea from the ONF under which both of these actually fall, is the fact that we don't want OpenFlow anymore. We want to keep the vOLTHA protos, the vOLTHA core northbound protos, and those have to be upstreamed and maintained uniquely in the open source. So any change that goes there, independently of who does it, needs to come in the open source. And I cannot stress this enough. Otherwise, the moment this does not happen, effectively, we are having separate, I don't know how many, forks of the project that will be non-reconcilable effectively anymore. So while the first point could even be up for debate if we get together and come to an agreement of working on one, or people decide to go their own way and work on two controllers, that could be up for debate. What I cannot accept that is up for debate is that the protos change and the change does not come into the open source. That is my mandate that I would like to really enforce. The development, I cannot enforce anything. But the protos is the real important thing that needs to come into open source, any single change. On the working together front, this is not something that I can decide. Obviously, I could say that my preference would be to have this this controller be unique for both of the vendor solutions that are coming to support and use vOLTHA, because that would mean less effort for anybody. And I would also have to say that as ONF, and maybe as a community, it would be very difficult for me to maintain two sets of tests for both of these. Meaning that at the moment we have a test suite that runs, I made the calculation like 1 week ago or something like that, it runs 685 total tests a night. That's a huge number. That's different pods, different types. So it's obviously a repetition of the same tests in many places, but moving this and duplicating the number of tests, reaching 1,300, because we have 2 controllers, that would not be acceptable by myself or even the community at large. And the follow-up point is that there are 2 roads here. One is that we come to an agreement of the controller and everybody works together on 1 controller, or, which I would not like, both controllers are developed and then proposed to the open source, and the ONF, just the community, we just choose 1. And the third one is that we actually don't choose and still stick with the ONOS, which I don't like because nobody's going to use it anymore. So this is the situation we're in. And then my question really turns to Radis and Netsia. And maybe this is not even the place where we can start answering this question, but is there a path? Do you guys see a path for working together on a controller, which is based on either of your solutions, and that can be upstreamed, or you guys feel that you are at this point in time fairly far apart, that there cannot be a consensus to commonly develop this controller? I mean, this can be debated and can be discussed for further months, but weeks, and not even right now.
And yeah, I will go first. Sorry. Okay.
Oh. Yeah, please go ahead.
Okay, thank you, Sarkant. Let me just state a few things on the principles. We are absolutely willing and wanting to work with the community. As a matter of fact, since I don't attend the TST, I did not know about the Netsia proposal until very recently. And we highly respect everybody in the community here. It's a very small community. This is the community that has been remaining after many years now, ever since vOLTHA C was started. So I think we're a good group of friends. We're a good community. We have good ideas, and I see there are 2 good ideas on the table. One from Netsia, one from us, and we are very open and willing and wanting to work with Netsia and others in the community to figure and find a path forward to make sure that the final solution is indeed a performance solution that will meet everybody's needs. So that's our approach towards addressing this, Andrea. Sarkant, please.
Yeah, thank you. So I believe as a community, first we need to agree on the design, right? So we have 2 different design proposals here, and I don't care actually who make the implementation, but at least in the community we have the right design proposal, at least. I think we should continue with the design debates, and we should agree on the design, and later we should start the implementation. For us, actually, this design is not the way we wanted to go, because we have the IGMP application running in a Türk Telekom production. And it's a very time critical application that we really need to separate from the ONOS. And in the future, we wanted to have a different packet dispatching mechanism from the vOLTHA also to have the IGMP. Maybe we would run the IGMP application in the OLT itself. That's why we wanted to have the applications separately in a microservice architecture. That is all
I see.
I wanted to say. Yeah.
Let me a few sentences. Of course, I totally agree with Raj and Sarkant. I mean, we have discussed more on the design, that's for sure. But we are also open to, we want to work with open source community. I mean, we're ready to collaborate the works, yeah, but it should be planned. I mean, this is a new thing for us. I mean, we already started the work, you know, so, but we're open. Let's discuss this and in some separate meetings and take action accordingly. Yeah. But first steps should be, of course, I mean, align on the design and find the best solution. So go accordingly.
Excellent.
Yes, excellent. Yeah, I agree to that design discussion, and I do see your point, Serkan, about this highly time-sensitive application that needs to be apart from this. So what I could suggest is that everybody here could take the time to look at these two proposals and start to understand the differences and the strengths of each of these proposals. Myself as first of the community will do this, and we could next week discuss some of the strengths and weaknesses and differences that everybody sees. Like Serkan just said, for us, we need that piece, and we don't see it in this proposal. And the same thing could be done by the Radisys guys, and take a look at the Netzer proposal that was done last week, which, by the way, is public, and you guys can see it in this link. And you can also watch the recording from last week's presentation for TST. And then next week we could start seeing if we could at least come to an agreement on some of these requirements that are missing from both ends, and come up with a common solution on the design perspective, which I believe was maybe somewhat similar to what we had originally at ONF. So there is that proposal link also over here in there. So if anybody wants to read that one as well. And that is my thought. Would that be fine for everybody?
Fine with us, Radisys.
Yeah, fine.
Just
Okay.
a quick question. Like it's we've been talking about the design, but in terms of the interfaces, like looking at the Radisys proposal, like and even in Netzer proposal, like the southbound interface, the one that connect with vOLTHA, is always like that's not changing. So there is a set of APIs there that it's good that we're abiding to that interface. But in a northbound, are there a set of APIs that needs to be followed by both sets, by whoever implement a microcontroller needs to have that set of APIs. Like I can in the one from Radisys, we have this REST, and you kind of mentioned it's a different. There's a change in the REST. Is there a way to make it standard, like quote unquote standard, so that any controller will abide to that?
That's a very good point, Ken, and thanks for making it. That would also be, I think, very valuable in any case and decision we make to have the northbound APIs be the same. And I could go and I could venture as far as say, why don't we consider some already existing standard like BBF, for example? I'm not so familiar with what's out there. There are many people that are, but maybe we could reuse some of the service provisioning, because that's what we're talking about, from existing APIs, existing Yang models that thus make it compatible and compliant with anybody out there which speaks those APIs. If we cannot come to an agreement on using some existing stuff, let's at least design one that can be reused by all if multiple will not willingly, but if multiple controllers decide to still be implemented. Yes, that's
Andrea,
a good point.
Andrea, yeah, that's a good point. And don't we have the APIs defined in SEBA-RD?
Yes, there are there. They are defined. if what you're saying is let's move those to Proto and call it a
Yes.
day, I can.
Yeah,
I could
maybe. Yeah. This may be a solution, I guess, at least for start.
And a separate question, like out of curiosity, like since the Radisys proposal is in production, what kind of performance are we seeing on it? Like how many flows, how many devices that it's supporting currently?
Sorry, can you please say that again?
Yeah, since your proposal, well, whatever you have there, this micro ONOS is in production, right? I guess you have run some performance tests against it to compare with the current ONOS. What kind of performance are you seeing in terms of flows, in terms of devices that you're supporting?
Yeah, so we measure the performance as the full stack. I mean, not just the ONOS and vOLTHA, but the overall full product. I have to look up those numbers and probably share next time we meet.
Okay, that's all right.
Maybe it's, I think the ONOS also has atomics, etc., right? So from what we have, at least what we have observed, the CPU utilization of ONOS was not predictable in the sense that sometimes it would take up, if you offer 10 cores, 20 cores, it would take up all of it. I think it's atomics or ONOS, I don't remember, or both. So it was not very easy for us to compare either, but nevertheless, I'll try to look up some information to give a ballpark number, if not, right, very a reliable number. I should be able to give you some ballpark number.
Yeah, thanks. Just an idea on performance gains would be good.
Sure, yeah.
Okay, so before we run out of time, let me restate what are the action items from this. The Radisys team will take a look at the NetSail proposal. NetSail team will take a look at the Radisys proposal. We as ONF will take a look at both of them, even though I fairly know both of them. And then next week, we can maybe go into some of more weeds of what is missing from an ideal point of view, from what we would actually would like and is missing from one and from the other, if a combined solution can be achieved. And also a definition of the protos. I can take a look at the SIBA RD ones and see if those map properly with some protos that are existing, some YANG that are existing, and worst case, we can just write them in protocol. For those, for the ones that we don't have already in vOLTHA, because some of those are already in vOLTHA. Would that work for everybody?
Yeah, we will. Yeah, we'll come prepared with a review of the NetCS proposal for I think 22nd, right? The next meeting.
Yeah, that would be the 22nd. Yes, same time. Okay, last item before we go, and then I'll let you leave, is that thanks to Girish, we now have a very well detailed document for combo PON support. I know this is a hot topic and it's interesting for a lot of people in this call and a lot of people in the community. And this is our proposal to see through the support of combo PON OLTs through OpenOLT agent and vOLTHA. So feel free to take a look at it. If we have some time, Girish will present it next time, hopefully, or as soon as we have some time. The controller takes a little bit of precedence over this, but feel free to take a look at it and share it with your low-level, maybe device experts that can provide us feedback. The goal would be to finalize this document by 2.10, so in the next month, and then start maybe an implementation. We do have some external dependencies like BAL and Broadcom and other APIs for the OpenOLT agent to make this support available. We could start looking at possibly using BBSIM as a way to develop it in the existing vOLTHA stack. And then when the time comes for the OpenOLT agent to integrate it with BAL, we could use that. So feel free to read the document. It's here as you can see it. And share some feedback for myself, Girish, and the BAL brigade as soon as you can. So thanks a lot for that as well. Okay. I know we are over the hour, but let me just take the time and say, is there any other topic that would like to be discussed? Anything very urgent to be shared? No? Okay. Then if not, thanks everybody for joining. I'll publish the recording as soon as I can, and have a great rest of your day. Cheers. Bye-bye.
Thanks. Bye.
Thank you.
Thank
Thanks all.
Thank you.
Great
Thank
session.
you.
Thank you.
Bye-bye.
Bye.